Sulfur is going to do the same thing. Sulfur will get a -2 charge and gain 2 electrons. Trend continues. Fluorine is going to gain 1 electron for a -1 charge, and chlorine is going to gain 1 electron for a -1 charge. Everybody who's in this last column here, their valence shell is full, so they do nothing. They are the noble gases, often called inert, because they're not going to lose electrons or gain electrons. Sometimes they'll share electrons to form a covalent bond, but they're never going to have any sort of charge to them. Next, I'm going to talk about naming and bonding and writing the formulas. So the first thing that we should always do when we are looking at any sort of chemical name is determine, is this an ionic compound or a covalent compound? So first of all, if we have an ionic compound, we are going to have a metal bonded with a nonmetal. And so you need to know where those are located on the periodic table. So everything over here in this section of the periodic table, those are going to be considered our metals. And everything that's over on this side of the periodic table are going to be considered our nonmetals. So if I look at the first one that I have written here, I've got magnesium chloride. So I'm going to look and I'm going to see magnesium's on the left side, means it's a metal, and chloride is chlorine, and that's over here on the nonmetal. So that's an indication that I've got an ionic compound. If I look at the second one, iron 2 bromide. Iron is over here on the metal side, and bromine is over here. Again, I have an ionic compound. Copper 2 hydroxide. Now, hydroxide is not on our periodic table. That's going to be a polyatomic ion. It's on the back of your periodic table. Hydroxide is OH with a negative charge. Now, what actually happens is these two guys bond together covalently, which I haven't talked about yet. Give me a second. And when they bond together covalently, they end up with a charge to them. So polyatomic ions, many atoms bonded together that have a charge, hence why it's called an ion. So copper is over on this side of the periodic table. He's a metal, and hydroxide is a negative polyatomic ion. Hydrochloric acid, since it's an acid, that's going to be an indication to me that it's still ionic. Acids are ionic compounds. Hydrogen is going to be the first element in our acid, and then it's bonding with another element. So the hydro tells us that we've got hydrogen with chlorine. So now that I know that all of these are ionic, I'll talk about covalent next, but all of them are metals with a nonmetal. So when I make the formulas, I've got to make sure that my charges are balanced. So based on what we learned in the previous piece of this video, what kind of charge would magnesium have? Well, I look at my periodic table and I look at where he's located over here, and I see that he's in the second column of our periodic table. So that means he's got 2 valence electrons. He's going to go ahead and he's going to lose those 2 valence electrons and end up with a positive 2 charge to it. If I look at chlorine over on this side of the periodic table, he's in the 7th column. So he's got 7 valence electrons. He's going to gain 1 valence electron to finish off his shell. So he's going to have a -1 charge to him. So now the problem is that magnesium is giving away 2 electrons, but chlorine only needs to gain 1. So if I think about it like this, here's the 2 electrons that magnesium is giving away, and chlorine needs to gain 1 of them. So here he goes. Magnesium gives an electron to him. But magnesium has another electron to give away. So we need another chlorine to come on over so that he gets another electron. So 1 magnesium is actually going to need 2 chlorine ions in order to balance him out, in order to make sure that there's somewhere for all of his electrons to go. So if we think about this, then we've got chlorine with a negative ion and chlorine with a negative ion. We have a total of -2. That balances out here. So when we put our formulae together, it's going to be MgCl2. The same idea works for the next ones. Now, iron 2, the 2 right there tells us that we've got a positive 2 charge. So when iron 2 is used and I've got a positive 2 charge, I'm going to go ahead and erase this here. That means that iron is losing 2 electrons, just like the magnesium lost 2 electrons. So iron is going to lose, he's got 2 electrons out here, he's going to lose those 2 electrons. Well, they got to go someplace. So if I look over at bromine, which is right here, I look and see, well, he's got 7 valence electrons. So bromine needs to gain 1 more valence electron. He's got 7. 1, 2, 3, 4, 5, 6, 7. So he's going to gain 1. Well, what's iron going to do with that other electron? So we need another bromine to come over so that he can give another electron. So here's what we've got, is we've got iron with a positive 2 charge. And bromines are typically going to get a negative charge because they're going to gain 1 electron. Well, I can't just have 1 bromine. I'm going to need 2 bromines in order to get both electrons from that iron. So the formula for iron 2 bromine is going to be iron or bromide, iron, and then Br, and a little subscript here of 2, just like we did with the chlorine. So the subscript tells us how many of each of the different ions we need in order to balance it all out, in order to make sure everybody's getting and losing the right number of electrons and make sure that it's all neutral in the end. So if we do copper 2, that means I've got copper with a positive 2 charge. It's losing 2 valence electrons. Well, hydroxide has a negative charge. He's only going to gain 1 electron. So if my copper's got 2 to give away and my hydroxide's only got 1 to gain, well, I'm going to need 2 of those hydroxides. Now, when we need 2 of a polyatomic ion, when we write the formula, we're going to have to put parentheses around that polyatomic ion and then put our subscript right underneath it like that to show that we need 2 of them. So you've got to keep that in mind. We don't want to just write CuOH2 because this would only tell me that I need 2 hydrogens in it. And I actually need 2 of these whole pieces. These guys come in big chunks together. So I actually need to have 2 of them there. So that's how we write copper 2 hydroxide. Hydrochloric acid. An acid is always going to be hydrogen. Well, hydrogen is in the first column over here. And so that hydrogen has 1 valence electron. He is going to lose that 1 valence electron, get a positive charge. Chlorine, we've already talked about how chlorine's got 7 valence electrons. He needs to gain 1 with a negative charge. Well, that's perfect. Hydrogen and chlorine balance out perfectly to get HCl, and that would be your formula for hydrochloric acid. Let's talk about a few more formulas and writing a few more of them. So if I have got dinitrogen pentaoxide, right away I should notice the prefixes. Prefixes in a name is going to be an indication that we have a covalent compound. So only covalent compounds are going to have these prefixes of di and penta to them. Now, what's a covalent compound? Well, a covalent compound is going to be a compound that is 2 non-metals. And so on our periodic table, we have to know that our non-metals are located over here. So these are going to be all of your non-metals. So we should notice that this particular one is nitrogen, which we can see is right here, and oxygen, which we can see is right here, 2 non-metals. So it's a covalent compound. So I don't have to worry about number of electrons being given away, number of electrons being gained, balancing out charges. I don't have to worry about any of that. All I do is I use the prefixes to write my formula. Di means 2, so that means I've got 2 nitrogens, and penta means 5. So that means I have 5 oxygens there. That's it, okay? If I was naming this, if I had something like sulfur 2s2cl5, then I can see that I've got 2 nonmetals. If I identify those 2 elements, here's sulfur, here's chlorine, and I would name them simply by putting in our prefixes, disulfur, and then pentachloride. I don't even know if that is an actual, I'm just making ones up just to give you an example of how it works. Pretty simple when it comes to the covalent compounds, but the first thing you've got to do is identify if you have nonmetals, if you've got 2 nonmetals. So you've got to be able to look over at your elements, nitrogen and oxygen, and go, oh, they're both over on this side of the periodic table. So I've got a covalent compound, and I'm using prefixes in my name, and I'm simply using the numbers that correspond with those prefixes. Now, acids get a little bit more complicated. Hydrochloric acid was very simple on the previous video. Acetic acid, we're still starting with hydrogen, and hydrogen loses 1 electron. But acetic acid, since it's not starting with the word hydro, that's an indication that we're using a polyatomic ion. And when a polyatomic ion is used in an acid, the end of the name gets changed. So in this case, the ending is ic, which means that the previous polyatomic ion name must have ended in 8. So I look for something that's called acetate on my polyatomic ion sheet, and acetate is C3H2